We're going to look at our calculator and explore linear functions. And our goal here is to understand what certain parameters, the effect it has on a linear function. So that's the goal of what we're doing today. So what I'd like for you to do is look at these instructions and read them. It says this, it says using a graphic calculator, start with the standard viewing window, which you can obtain by pressing zoom. So press that on the calculator, please, zoom. And selecting Z standard, so that's number 6, so I can arrow down or I can just press 6, either way it'll work. Now, because the distance between the consecutive tick marks and the x-axis and the y-axis are not equal, you can make them equal. You can press zoom and click on Z square. That's number 5. That squares everything out. And if you want to understand what's the intervals on which the axes are set up on, you can press window and see that the minimum of my x-axis is negative 16, the max is positive 16, the minimum of my y is negative 10, and the max is positive 10. And by the way, you can change those settings to change the graph. And if you do, just remember to put it back to normal, you can just press Z standard or Z squared. All right, so here's how we're going to begin. I want you to graph the function of f of x equals x. Now we're going to do so by pressing y equals, and we'll press y equals x. We want to graph that function and go ahead and press the graph key to see what that looks like. So that's my blue line. And it is the graph of y equals x. And this graph makes a 45-degree angle with each of the axes. What's the slope of that line? What's its y-intercept? Yeah, the y-intercept is 0. And the slope is 1. In other words, when I run forward 1, I rise 1. So here's some more instructions. We want to graph other functions of the form of f of x equals x plus b. In other words, we're going to see what happens when we add to the end of the equation. And so we want to do so. Well, let's try a couple of values. It tells you f of x equals x plus 2 and f of x equals x minus 3. So here's what I'm going to do. I'm going to go back to y, and I'm going to arrow down, and I'm going to enter x plus 2. And I'll go down one more and try a different graph here. This one will be x minus 3. And what's going to happen is when I press the graph button, it'll graph all three on the same. And the first graph will be blue, the second will be red, and the third one will be black. So watch as it graphs it. So what do these three graphs, what do they have in common? The slope is the same, right? Yeah, the amount of steepness is the same. And how are they different? What do you see different about these three lines? So the difference I immediately see is all three have a different y-intercept, don't they? So what's really going on here? Well, when we add 2 or subtract 3 from the function y equals x, we have something we call a vertical translation, okay? And what's going on when we say vertical translation is that we're moving all the points either up or down. So let's write that definition. Vertical translation moves all points on the figure the same distance either up or down. Vertical translation. That's found when we add to x. For example, the first one was f of x equals x. That went through 0, 0. But then that red one was f of x equals x plus 2. It moved up 2 units. The black one there was f of x equals x minus 3. It went down from this original one. It went down 3 units. And so when I say up 2, for the second one, I'm saying up 2 from the original one. When I say down 3, I'm talking about down 3 from the original equation. So if I say this equation has been moved up 3 units from my starting equation, I would call that a vertical translation. Well, let's experiment some more. This time, let's look and see how the graph is affected when instead of adding, we multiply x. So go back to your graph, and we'll clear out everything but the first one. So we'll leave f of x equals x or y equals x. Then we'll clear the others out. And so the first one I'll write down 2x. And I'm going to try some other numbers, 6x. I'm just getting a little crazy. Let's go 9x. Why? And let's see what those graphs look like. Oh, wow. So what do all 4 of those graphs have in common? What do they share? Yeah, they share a y-intercept. They have a y-intercept in common, but what's different about those 4 graphs? They vary in their steepness, don't they? You see that? I mean, that last one, the y equals 9x, it's by far the steepest. So what happens then as that value of m, what I'm multiplying x by, what happens as it gets larger? Can you tell me? I mean, this first blue one was y equals x. The second one, the red one, was y equals 2x. The black one was y equals 6x. And that purple one's y equals 9x. Is that number that I'm multiplying x by, that coefficient of x? Here's my word. Coefficient of x. As it gets bigger, what's happening to the line? Do you see it? What's it doing? It's getting what? Is it steeper or less steep? It's getting steeper as that number, as that coefficient of x gets bigger. The higher the coefficient, the larger that coefficient, the steeper the line. Well, let's experiment some more. Let's go back and clear everything out except for the y equals x. Do that right now on your calculator. And let's try multiplying by numbers between 0 and 1. That'd be fractions. So your notes here say try 0.5x, try 0.2x, try anything you want to. What happens there is on graphic notes. That line, the blue one is y equals x. So 0.5x, the red line, it's not as steep, is it? And the black line, it was remember 0.2x, it's not as steep either. Let me try something a little crazy. Let's try this. Let's go y. We'll go down here. I'm going to use a green line so it kind of shows up. Let's try a fraction. Let's try 1/50th. Wow, that's a tiny little fraction, isn't it? Okay, that's what happens when I graph that. Whoa. What's that green line doing now? It's kind of hugging the axis in it. It's almost zero. Now think about it. It kind of makes sense. As it's getting closer, as that fraction gets smaller and smaller and smaller, as it's getting closer to zero, my slope is getting closer to zero too. Makes sense. Zero slope's a flat line, right? So if I end up multiplying by zero, it's going to be a flat line. The closer my fraction gets to zero, the more level my line. All right, let's try something else. Clear out everything but y equals x. Read the instructions there in your notes. This time we're going to try one different thing. Now this time we're going to graph y equals negative x. Press the graph button, see what happens there. What do you see? What do you notice about that line? What do you see? Well, the blue line's the first one. It has a positive slope from left to right. It's at a 45-degree angle with the axes. The red one is negative x. It's like the same thing, but now it's a negative slope, or it is downhill from left to right. Do you see that? So the positive and negative coefficient of x, it affects whether it's going uphill, or if it's negative, it's going downhill. Try one more thing. Let's try this. Let's go between 0 and -1. So I'm going to clear it out again. And we'll leave y equals x. This time, let's put negative 0.5x. Let's try that, and let's try negative 0.2x. What do you think will happen in that graph? It's going to be a downhill slope. And depending on fraction, notice what happens. It starts to level out as that fraction gets smaller. We've got some important definitions here. I want you to write this down. A family of functions. Okay, and if you're looking at your slide, you'll notice on the second slide I've given you a real official definition. But a family of function is a set of functions that share it says it has some basic characteristics, okay? talk about a family, a function that we're studying right now. Does anybody know what the function family here, what we might call it? We've used this word a lot. I'll give you a hint in a minute. The word begins with L. What kind of functions have we been graphing? Yeah, linear. So this family of functions are linear functions. We'll be talking about other families throughout the course of the year. We'll be talking about quadratic functions. We'll be talking about exponential functions. There are cubic functions. There are all sorts of families of functions, but these all share that same characteristic of they graph as a straight line. Remember, when we began this whole unit, we looked at what made a function linear. Remember, it had no exponents, and x couldn't find itself in the denominator. The parent function is the most basic form of a function in a family. Now, these are some pretty important words, and just like earlier, the word coefficient, we need to get used to kind of using that. The parent function, the most basic, you might call it the daddy function. In linear functions, the most basic function, the parent function, is f of x equals x. That's why I kept starting with that one each time we graph. That was the parent function. Y equals x. Okay, and then the family is y equals x plus 1, y equals x minus 3, y equals 2x, y equals 2x plus 1. We see the steepness changing of the line. We see it's either moving up or down, that line is. We see all those things. That's the family. And the parameter of the function are those parts, okay? I think that we said they're constants, but they're the things, the pieces, the constants, the actual numbers that have an effect that determines the variation on a parent function. So a parameter is that, and I'm going to kind of make a little less of a mathematical definition because the next slide you have a real mathematical, but it's the numerical part okay, or the numbers, what I mean, that causes the variation from the parent function. In those that we've seen so far, that was where we added 3 or we multiplied x by something. The two parameters are my vertical translation, moving it up or down on the x or y axis, or the steepness of the line, which is that number in front of x. We've been calling slope or constant rate of change. We've named it 2 or 3 things. I'm going to show you a couple of slides here. I don't expect you to handwrite these down because you'll find them on your copy of the notes in Google Classroom. But I just want to show you what we're talking about here, okay? So once you get that written down, I'll let you put your pencil down and look up. That way I know everybody's got those notes taken. I'm just waiting on a couple more, but take your time. Just jot that down and then move on. All right, so let's look at a graph. The parent function here is the one in the center. That's the y equals 2x. Well, actually, the parent function is y equals x, excuse me. But y equals 2x would be a function that has a little steeper line. In other words, when I run forward 1, I rise 2. We know that that's how the slope works. Then notice that this line where it's y equals 2x minus 1 has been translated down here 1 unit. And this one, y equals 2x plus 2, has moved up 2 units. So we can see how the adding or subtracting affects our line. It's just going to move it up if it's plus, down if it's negative. And it gets steeper if the coefficient in front of x, the larger that number is, the steeper it is, the smaller the fraction, the less. Here's another similar kind of set of equations. And this one, it does the parent function is y equals x, but we're going to start out with y equals x plus 1. But what we notice is that, and this is y equals x plus 1 here, but we notice that the slope is doubled here. And so we have a steeper line, or here the slope has been given a -1, and it flips it. So that it's the same thing, except now it's going downhill. For every one it goes forward, it goes downhill one. These we call transformations on functions. We can transform them just looking at the equation. Well, let's look at that, what that might look like in words. All right, so don't expect you to write all this down, but do expect you to listen. Hang on here for a second. The gym charges a one-time new member fee of $50. Now, we've learned over the past several weeks that when I say you charge a one-time membership fee, that's a y-intercept. In other words, we start right there, $50, okay? We're going to charge that right up front. We know that. And a monthly membership fee is $25. So that's a constant rate of change because every month I'm charging $25 more. So the total cost of being a member of gym is given by this function, C of t is equal to 25t, in other words, $25 per month, with an initial amount of $50 being charged, the y-intercept of 50. All right, so there's the graph of that, the way it is. So what happens if the gym decreases its one-time fee for new members? What do you change if you just decrease that one-time fee? The answer is, well, I decrease the y-intercept. It's going to go down. So like here, if I made that one-time fee $25, my graph goes down. $25 on the y-axis, down 25. Well, if the gym increases its monthly membership fee, okay, so let's go back and let's say the initial fee, the one-time fee is the same, but we're going to increase how much they charge per month. And what happens is the y-intercept will remain the same because we're back to the original one-time fee, but the slope is increased because I'm paying more each month. All right, so having kind of answered this, let's look at these, see if we can answer these. Suppose the gym increases its one-time new membership fee and decreases its monthly membership fee. What would change? How would you graph that? So it increases its one-time membership fee. All right, so I'm going to add to this portion, and I'm going to charge less per month, so I will decrease this portion of it. Now, they haven't told me how much, But that's where I deal with it, okay? I'd raise the price right here, so it becomes 25T plus, let's see if we increased it by $25 plus 75, and I made it $10 a month, it'd be 10T there. Once a year, the gym offers a special in which the one-time fee for joining is waived. We don't charge that. What impact would that have on the graph? Anybody tell me that answer? Here's the graph, right? C of T equals 25T plus 50, and I waive the one-time fee. What does the new function look like? I believe you can get this answer. What's the new function going to look like? What's it going to be? I waive the fee, means I don't charge it. Means it's 0. What does the new function look like? Dare you to answer. What do you think? Some of you are afraid to answer. What part do I change? Do I change the 25 that's in front of T? Or do I change just the 50 portion? Remember, my one-time fee is my y-intercept. What do you think? You're going to be, oh, that was too easy when I show you. Let me show you. My monthly fee hasn't changed, has it? So my slope doesn't change. My constant rate of change doesn't change. What have I gotten rid of? The one-time fee, right? So it starts at 0. So I'll leave this portion out. Or I could say plus 0, but I don't need to do that, do I? So how does it affect that function? We no longer move the function up by 50 places. We just leave it at 0. So my one-time special offer without an initial fee would just be C of T is equal to 25T. So those are the parts of the equation that affects how we graph. Those parameters, whether it be a vertical translation or how steep the line changes from our parent function, we can use those things to rewrite our equations to do whatever we need them to do. We just need to understand the effect that those parameters have on the line. That's what we call transforming or transformations of linear equations.